Recording is rolling. It is Friday, April 12th. Gonna finish FRQs from yesterday. Well, between yesterday and today, had about 84 minutes. You guys remember the official time to get to do those is about 90 minutes, so pretty close. Okay, guys, make sure that your handwriting is legible. Because you guys remember next week we're going to do a trade and grade. We've done that in the past, right? So make sure that your classmates can read your handwriting, right? Same thing for the actual FRQs that you're going to get a few weeks from now, is that you might possibly have the correct physics, you may have the right answer, but if the grader cannot read your handwriting, that you're not going to get the points, right? Right. I did staple a blank paper on the back. I'm going to recommend maybe, especially for the experimental design, that you refer to that. So whoever's grading your paper, maybe they're looking for notes. It's like refer to that page on the back. If you need more paper, let me know. I can get you more paper too. Right. If you finish by the end of class, then awesome. If not, if you have a little bit more, then you can finish that over the weekend and then bring that in Monday. Right. Tell you what, too, if you finish by the end of class and you're like, okay, I just want to stop my hands, I don't want to lose it over the weekend. If you want to turn it into the gray tray, then that's all right. I can get it back to you on Monday. If you want to take it home and bring it back Monday, you can do it that way too. Okay, you guys get that? Right. Oh yeah, here's a top scientist for the multiple choice part that we've been looking at over about the last week. So awesome job if you are on that list for top scientists. Right, and before I let you guys go finish this FRQs real fast too, I want to fill you guys in on what my honors classes are doing, because you guys missed a few things. They're dealing with electromagnetism, so I'm having them do 3 mini labs today and have them construct these things. So I wanted a quick demo for you guys here. So compass, I got bar magnets. Now the poles on these magnets are on the faces, so this is either south or north, and this is the opposite, either north or south. If you click a bunch of magnets together, right now you have one giant bar magnet, right? But all magnets are going to have 2 poles, right? Always the north and the south. Now, I don't know which side is north and which side is south. So what I'm going to do is I'm going to drop these in this cup horizontally, right? So I know the poles are oriented horizontally, right? And then drop this in this cup of water, right? And this will naturally orient to Earth's magnetic field, right? It's been doing that all day today. I don't know what that's about, because usually good. Anyway, that's what it's been doing. So I could orient this any other direction, and it's always going to go back, right? It's going to align with Earth's magnetic field, basically, north south that way. Right, so there you go. There's a basic compass. Right, electromagnet. Right, so I've got volts, batteries, paper clips. Right, now right now there's nothing actually magnetic on the screen. Right, so I can try to pick up these paper clips. Nothing. Right, I took a wire. Right, I wrapped it around. You can also call this an inductor. You just do this with the wire, just wrap around a bunch of times. It's called inductor. Right, turn. Right, hook this up to batteries. Right, so notice I got the end stripped. Right, hook this up to a battery. Now there's a current flowing through that coil, which is going to turn this into an electromagnet. Right, so I should be able to pick up the paper clips now. So I have a good connection here. Good connection. Let's go with that. Let me try a different battery. All right, there you go. Oh, look at that. Good strong magnetic connection. I can pick up these paper clips. Right? And then as soon as I open the circuit, right, break off the battery, boom, right, loses magnetism. Right? So that's an electromagnet. Notice I had no permanent magnets, right? Just batteries and wires and bolt. Right? Right. Last one I want to show you guys is a motor. Right, now this one's a little tricky, but this one's fun. So I'm going to bring in back a stack of permanent magnets. So got the permanent magnets back. Okay. Got a battery with the leads extended. If you want to do this, make sure the paper clips are touching the leads of the battery. That's the idea, right? Okay. I got a little inductor here, right? So just wrap a wire around and around. The middle is insulated, but the ends are stripped so they can make contact with these paper clip leads. Now I got a circuit going. This is the magnetic field, and it will spin. Okay. Now, guys, how long is that going to spin for? Exactly, until the battery runs out, right? There's a finite amount of energy in the battery, and chemical energy turn electrical energy turn into mechanical energy. Right? That conservation of energy, that energy comes from somewhere. So there's a finite amount of energy there. Yeah. I'll show you guys one more thing too, which is a motor and a generator are basically the same device, but doing exactly opposite processes. Generator, you take mechanical energy, run a wire past a magnet that'll put the energy into an electric current. Then a motor takes that electric current, run that past a magnet, and they'll turn it back to mechanical energy, like turn a ceiling fan, for example. Right. So let me show you guys the generator side of this. I got this Faraday flashlight, magnet, foil wires like an inductor. Right, so here's mechanical energy converting into electrical energy so that you can turn the flashlight on. Boom, there you go. Okay. All right, so I guess go ahead, work on your FRQs. Hopefully finish those by the end of class. Not then, you can wrap up the rest over the weekend and get those in. Monday, we'll score those.